In this video, we will see a program for the doubly linked list, and at the same time, we will observe the difference between the two, that is, between the singly linked list and the doubly linked list. You see, this is the header file in all C program, and in all programs related to the linked list, I have taken an additional header file, and that header file is stdlib.h. Now I go directly to the main function because in this I will not use any other function. And here, you know, a linked list is a collection of data, and the data may be of integer type, float type, character type. But here I take the data of the doubly linked list to be integer type. Accordingly, I have taken a variable here. Now I declare the node for the doubly linked list. A linked list is made of similar nodes. Since a building is made up of bricks, so here our linked list is made of node, and this is the node. I type here a struct node, and inside a singly linked list I had taken there two types of things inside the node. Here is the first one, int data, and the second is the self referencing part, and that is a struct node star next. These were also present in the singly linked list, and the second thing is the link part. But here in the doubly linked list there will be two links, and so I have to take one more self referencing part, and since the two parts are different, so here the first part I name it with a star pre. This means that this denotes the backlink, and here you see this denotes to the fourth link. So in this program for the doubly linked list, you see the node, and inside this there are three parts, and this is the reason the doubly linked list consumes more space. And now after that we declare three variables, and these three variables were also present in the singly linked list, and these were star first, star move, star temp. You remember? Okay. Now I take a loop. Why? Because a linked list, whether it be a singly linked list or doubly linked list, both contains many elements inside it, and to take accordingly many nodes and to attach two consecutive nodes, we run a loop. And here I take an infinite loop, and to work with infinite loop it is necessary to control this loop, and to control this loop, one way to control this loop is to use a scanf function inside its body. I will use, you will see later. First, I create a node. You know, first thing is to create a node. I create a node and the name of the node is temp. Always remember whether it be first run, second run or third run or any run of this while loop. The name of the newly created node will be the temp. And here, what is the type of this temp? Here, first we type the temp, this the nature of this temp, and you know its type is a struct node star because you can observe here a struct node. Here you see a struct node for all, whether it be a star first or a star move or a star temp. So a struct node, and accordingly here you see a struct node. And one more thing, its type is a star of a star type because with temp here is a star, so accordingly I have typed here a star. Now I type the malloc function because it is the function which creates this temp node. And after that we type for the memory space, you know, any variable any variable later takes a space in the memory. And what is the amount of space, and for that here we take size of, and the size will be struct node because only a struct node, because a struct node, here inside a struct node you see you have taken three variables. So here a struct node, here is the struct node, and the same thing should be written here, but this struct node thing written is same as was in the singly linked list, but both nature of the both nodes are different. In the current node you see there are three things, but in the singly linked list, in that there was only two things. And now the you know the second thing is to store a data into this node, into this newly created node. When you used the malloc function, then that means this temp, that is the first node, is created. Now the second work is to store a data into this, and for that, and that data will be taken from the user, and for that we first show a message to the user, enter the data. When the user sees this message, only then he will enter a value, and you know the value entered by the user should be stored, and for that we use a scanf function. And since the data is the integer type, so %d here, and here the data is stored at an address, so here element, because element is an integer type variable, and the data taken is also will be of integer type, accordingly here element, I have typed element, and ampersand is there to point to an address. And now so far we have written three C statements inside this while loop, and with this we got a new node. Also we took a data from the user to insert in this node, but I have not inserted this data under the variable name element into this node temp. For that, but before inserting this element into the node temp, I have to type a condition, because this is an infinite loop. This means that this loop will run forever, but a user cannot be with this program forever, and so this loop should end at a desired by the user. And for that I take a condition, and a user may take any condition according to his her choice. I take a condition, and that condition is element less than 0. This means that element is negative, and when this happens, then I want to be out of this loop. So for that I have used here the keyword break, and this keyword break helps a user to come out of this loop instantaneously. Okay, now the temp, we have a node named temp, and inside this we enter the value stored under the variable name element, and I go to insert this value into the temp. And for that I here take the node name, and here temp arrow data. This means that data inside temp, and I assign this the element. The variable name is element. So writing this cs statement, the element inserted by the user will go inside the node. And now we have assigned the value for the integer part, and still there are two parts remaining. This link part, both are the link parts, because in both you see star. So these two link parts will be assigned null, and here I type accordingly temp arrow pre. This means that pre in temp here equals to null. This means that pre in temp has been assigned null, and accordingly one more C statement for this third C statement, third thing inside the node, and accordingly that will be, you can understand, temp. Next inside temp also, since this is a pointer, both links, both pointers, both addresses has been assigned null. Now so far I say once more, I have written many statements inside the while loop, and these statements are responsible to create the node, to take the data from the user. And now the last three C statements tell us that we have assigned the values for the three parts of the node. Now there will be a condition again. If first, suppose we have this time the first node, and so accordingly I type null. For the first node we have to work separately, because when you create a first node, then there is no need to attach with whom you attach. Remember, think, if there is a second node, then we can attach the second node with the first, but when you have a first node, then with whom you will attach? So we have to work separately for the first node, but for the second node, third node, the working will be similar. So accordingly I take here the keyword if only for the first node, not for the remaining nodes, for the first node only. And when you have first node, this means that the linked list is containing only one data, and you were questioned that what is the first node, what is the first data, then you will say this term, the data inside this term. And when you are questioned to say about the last data, then the in that case as well the last data will be the same, because the linked list is containing only one element. So the last element, whether it be a last element, whether it be a first element, both will be the same. So accordingly I type here first will be this term, and also the last. Here for the last I have used the variable name move, and the last will be the same, that is temp. And thereafter I use continue. Why? Think why? It is because since we have a first node for the first run, so there is no need to attach with this node. With whom you will attach this node. So I have used here continue. Continue means this continue keyword helps a user to come at the starting point of the loop, that is here. So accordingly I have used there continue. And now when you reach at the starting point, that is here, then what will be there? You will meet the malloc function again, and this time malloc function will create a second node because it is a second run, and thereafter again a message will be shown to the user, and he will enter the data, and that data will be the second data, and thereafter it will be checked whether that data is negative or not. If the data is positive, then that data will go into the second node. Remember, this time the temp is denoting the second node, and the data will be assigned, the second data will be assigned into the node temp, and the two parts of this newly created node, the two parts, that is the link parts, will be assigned null according to these two C statements. And thereafter, since this is a second node, so here we have to attach this second node with the first one. So here I type two C statements to attach this newly created node named temp with the first node named move. So this is a doubly linked list program, so there will be two C statements because we have to link these two nodes with two linkages. So first will be the same as was in the singly linked list, that is next inside move will be given temp. Okay, now there will be one more linkage, and this will be the new linkage because this linkage was not in case of singly linked list, and this is the basic difference between the two, that is singly linked list and this doubly linked list. And here I type the new node. The new node is going to be the last node, so here inside we take the previous. Here I have taken next for the first link, and here for the second link I take pre, but this pre will be of the new node, that is temp, and this should be assigned move. I have assigned. Now with these two C statements we have attached the second node named temp with the first one named move. And now we at the end of every run we make this variable move pointing to the last node, and here since now the last node is the second node, that is temp, so that temp should be assigned to this move. So accordingly I type here the C statement. Now our and I have attached the second node, and attaching of third, fourth, etc. are the same. So I am not going to discussing that attaching after second, that is third, fourth, etc. And if you and in this way your linked list go will be large and large. But at a at any moment you want to terminate this, then for that you have to enter a negative value. Here you see element less than 0. When you enter a negative value, then this condition will be true, and thereafter break comes into action, and this break keyword makes you out of this while loop. So the linked list is terminated. Now this linked list remains in the memory of the computer, and the user wants to see the list. Whether the user he wants to be sure that the data entered by me are in the computer's memory or not. For that we have to use one more while loop, and here I used while loop, and inside this I type first, because this first is the first node. First node equals to null, and this first will move, this variable name first will move from first node to the last. Since I want to see, I want to show the elements in the linked list, so accordingly I have to use printf function. And here since our data are integers type, so I take %d here, and to keep the elements, a linked list may contain many elements, so these elements should be kept at a distance, so I keep these elements at a tab distance. For that I have typed here \t, that is tab distance, and here I type uh, first first arrow data. This means that data inside first, and if you type so, then you will see the first data only. To see the later data you have to move this variable first, and to move, here is the C statement. First is slided to the next element, and for that this is the C statement. Okay, and with this second while loop you will see the elements in a sequence, that is you will have the first element at the first place, second element at the second place, and so on. And I show you the difference between the two lists, singly linked list and this doubly linked list. You can do one more thing, you can use one more while loop in this doubly linked list, which I am going to type. But this while loop you cannot use in the singly linked list. And here this is the second difference, and this difference comes due to the two links between any two consecutive nodes in the doubly linked list. And here I type the second, and inside this I type move not equals to null. And before using this while loop I here take one more printf function to uh, to to keep a distance between the two outputs. Here there will be a output corresponding to this while loop, and there will be a second output corresponding to this last while loop. So there are two outputs. So to keep a difference between the two outputs, I have used here printf function one more time, and this printf function will create a two new lines. So there are two backslash n inside this printf function. If you want to keep a distance of three new lines, so type there backslash n three times, and now here I take the body of this last while loop, and inside this last while loop will also show you the elements of the doubly linked list, but in the opposite order, because here you see move, and you know move denotes the last node. So the last element will be printed first, and the second last will be the second element, and so on. And again we type the same thing, and here under double inverted comma %d, and here will be this time move, and here data. And the second thing, you have, with this you will see the last element, and to see the all elements you have to move this variable move, and for that I type here move equals to move arrow, and this time you see here is the next, but since this is a this move is the this move is pointing to the last node, and you want to see the all elements, so you have to go back, and for to be back we have to type here pre, not the next. So you see this third while loop, and if you observe, if you notice the program, the similar program on the singly linked list, then there you cannot use this third while loop, because in this you see a link, a new link pre, and that was not there in the singly linked list, and this is the reason. And by this you also learn that in a doubly linked list you can traverse in both directions, forward backward, but in a singly linked list you can travel only in one direction. Here I say traverse. What is the meaning of traverse? Suppose you in a linked list, you know in a linked list there are many elements, and you go from the first element to the second, thereafter third, and at the end you reach at the last node, and your such movement is called traversing. And here the second while loop, with the help of second while loop you traverse in the forward direction, and when you use the last one, the last while loop, you traverse in the backward direction. This means that in a doubly linked list one can traverse in both the directions due to the two linkages. One link points to the forward direction, and the other link points to the backward direction. So this is the main difference between the singly linked list and doubly linked list, and this is the reason the doubly linked list is more efficient. And now let us see. And you know, at the end of each main function we type the keyword return 0. If in any program, if uh, if in a output of in an output of any program you see return 0, that means that there is no error in your program. If you are not seeing this return 0 thing in the output, then there is some, you may say, fault in your program. Now I run this program. Okay, it says to save the program, so I save. I have saved. Now it runs. Here you see it says enter the data, and now I enter, and here I enter 12, and you see that here there is some problem with this program. When you face such a situation and here you observe that return value is not 0, then in that case one should assign. Here I minimize. If it happens, then here here you see the first variable, and assign this variable the value null, and run the same program again. Sometimes it happens, and sometimes I see that the program runs well. Okay, but keep this in your mind. And here I magnify. Now I enter the data. Here it says enter the data, so you can take any data: 45, 6, 90, 56. Remember, you have to take the positive data. If you enter negative data, then the loop will be terminated, because there is a condition accordingly there in the program. And here now I want to terminate this program. For that I type a negative number, suppose -5. You can type any negative number, and I now press the key enter, and you can check. Here you can check the numbers, you can check the numbers, and the same numbers are here in opposite direction. 45, which was at the beginning, but here you see at the end. And the second is 6, 6, second last is 6, and here you see second element 6. And the third is 90. Here third is from the beginning. Here 90 is from the beginning, and here 90 is from the last. And here at the end you see 56, and that 56 is at the beginning in the second list. And here you see return a value 0. This means that our program is okay. But here you see there is a distance, but here there is no distance. This is because I have not used \t in the last while loop. I show you. I show you here. I have here you see in the second while loop I have used \t, but here it is not that thing. So I keep \t here as well. Now our program will show the output beautifully. Here are I magnify. Here I magnify, and here it says enter the data. So I take different data: 34, 67, 89, 45. You can take any number of data. Okay, now I want to terminate, so I take a negative number, negative integer, and here I press the key enter, and you see this time there is a space, you see in the second list as well, you see the spaces. Okay, now observe here the first element, and here, okay, the same was here, second, second is here, and third is also at its right place. But you see the last list, this list, then this list is in opposite order. You see 34 at the beginning, here it is at the last. You see 67 at the second position, but that 67 is at the last position. So the use of second while loop will give us the data in a sequence, and the use of the last while loop gives us the data in the opposite order, because in the last while loop the variable move points to the last node, and from the last point you come to the first point. So accordingly you have the data in the opposite direction, and this is the basic difference between the two. In a doubly linked list you can move in either direction. You can move forward direction as well as in the backward direction. But in the singly linked list you cannot move in both the directions. You have to move only in one direction. Okay, thanks. I show you the entire program once more. Here is the entire program. This is the first part of the program. This is the second part of the program, and here is the last part of the program. Okay, so write try to type such programs so that your C language may be strong. And one question I have to ask, and that question is here at the end of this program, here at this point, if I type at this point, if I use at this point first the variable first, then this first will denote the first node or the last node. You may answer. And in the same way here, if I use this variable move, then you have to say that at this point the variable move will denote the first node or the last node. Okay, thanks.